we have this question: let f of x be equal to modulus of 2x minus 3 minus 1. So they have told us to prove if the function is even, odd, or neither, right? So we know that for even, okay, f of negative x has to be equal to f of x, and for odd, alright, f of negative x has to be equal to negative f of x. So both even and odd have got negative x in them, isn't it? So let's check now. So what does f of negative x mean? It means while there is x, replace negative x. Okay, so this will be modulus of negative 2x minus 3 minus 1. Okay, now guys, the question I would ask you is this: is this the same as the original function? Is this the same as the original here? No, it's not, isn't it? And even if I multiplied by negative to make it odd, alright, this again is not the same as the original function, isn't it? So for this function, it's a neither function. How do you justify? You're going to say, since f of negative x is not equal to f of x, and f of negative x is not equal to negative f of x, therefore f of x is neither. Alright, neither. Okay, then they're saying state the range. Then how do you find the range? Okay, so number one, you have to understand that for modulus functions, if you have this, if you sketch it like this, right, you have to understand that domain, right, is a set of all real numbers. Is x such that x is a member of all real numbers for modulus functions. But the range, right, the range is dependent on what the number that is here is. Okay, so yeah, it's dependent on this, and also the sign for the modulus. So I'll give an example. If you have y is equal to plus or minus modulus of x plus or minus a. So if you're having positive modulus, meaning the range, right, the range will be y greater than or equal to whatever a is. Let me just say plus a, whatever a is. Then if y is equal to negative modulus, it means range, right, will be y less than or equal to whatever a is. Why am I saying so? Because when you sketch the modulus, let's take for instance our modulus is equal to like that, right? If you sketch it, it will be obviously like this. Range, notice what the range is. The range is starting from 0 going on top. It's going here, isn't it? So it will be y greater than or equal to 0. Now let's multiply a negative down here. So if we multiply a negative down here, it will go like this, isn't it? So the range will be y less than or equal to 0. Why is 0? Because there is no number here. There's no number here. There's no a. In other words, a is 0. Okay, that's what it is. So let's look at our question. Our question is saying y is equal to modulus of what? Modulus of 2x minus 3. Then minus what? Minus 1. Okay, so our range will be y. Have you noticed the modulus is positive? So positive means it will be greater than or equal to whatever a is. Now in this case our a is negative 1. That is our range. That is our answer. Y greater than or equal to negative 1. So meaning starting from negative 1 going on top. That's the way it is. Okay. Then the other part they're telling us is to sketch our function. Sketch the function, the graph f of x is good. Okay, let's sketch this. So how do you sketch that? So the first thing is parent graph. Alright, parent graph. What is our parent graph? Our parent graph is y is equal to modulus of x. Second thing is horizontal shift. Horizontal shift. Horizontal shift. How is our horizontal shift? Let 2x minus 1 minus 3, alright, be equal to 0, and x is equal to 3 over 2. Then the third thing is a vertical shift. Alright, vertical shift. What is our vertical shift? Y is equal to -1. So now we can sketch. So our first thing is a modulus, which is that straight line, and it starts from 0. Then we go to 3/2. 3/2 is 1.5. You can draw like 1.5 here, 3/2. So meaning instead of starting from here, you to start from there. I need to cut somewhere here. There, right? So this graph is y is equal to modulus of x. Then this one is a shift. Y is equal to the shift 2x minus 3. Okay? To know what this is a y-intercept. In the y-intercept, x is 0. You can replace a 0 there. You're going to have -3. Then modulus of -3 is 3. So this one is 3. Okay, we're done. So meaning this is gone. And we go to a vertical stretch or vertical shift, right? Vertical shift of -1. So the graph will go to -1. So meaning to go to -1, you're going to approximate your -1 as this one. So starting from here, to start from there, right? So your graph will be the same. Y is equal to 2x minus 3 minus 1. Now I need to find the y-intercept, right? Why is it going to cut in the y? So I'll replace 0 there. Y is equal to 0. If I place 0, I'm -3 that. So my y will be equal to 3 minus 1, because modulus kills the negative. My y will be equal to 2. So I know it will cut at 2. It will cut here at 2. Right? It will cut at 2. Also, so the graph will be like this. Like that. And like this. It will be like that. Now I need to know these points. I need to know what this point is and what this point is. How do I know what those points are? Okay. So I go into that. Those points are the x-intercept. In the x-intercept, x is 0. Okay. So the 1 can go the other side. So I'm going to have 2x minus 3 equal to 1. Then you know how to solve the modulus, right? You solve the modulus by putting plus or minus here, right? 2x minus, or saying 2x minus 3 is equal to plus or minus 1, meaning our 2x minus 3 is equal to 1, and our 2x minus 3 is equal to -1. So here x is equal to 2, and here x is equal to 1. Okay, because if this one goes here, it will be to 1. So this point is 1 and this point is 2. That's your graph. So this graph is y is equal to modulus of 2x minus 3, 2x minus 3 minus 1. That's how you sketch this graph.